Alright, next numerical is that 80 centimeter cube of a gas is collected at 654 mm pressure. At what pressure would the volume of the gas reduced by 40% of its original volume? Again, the temperature remaining constant. So this is what Boyle's law. Now, here if we see the given V1, that is equals to 800 centimeter cube, and P1 is equals to 654 mm Hg. Alright, and they are asking what is P2? What is P2? Where the original volume of the gas is reduced by 40% of its original volume. Now, whenever if you find this such questions where the gas is reduced by or reduced to, that is comparative study, at that time never take this numerical value. What you do is let V1 be equals to X and V2 will be now X. It is 40% reduced, so X minus 0.4X, where the reduction is of 40%. So X minus 0.4X, that is equals to 0.6X. So V1 is equals to X, V2 is equals to 0.6X. Now, temperature remaining constant, therefore according to Boyle's law, P1 V1 equals to P2 V2. So P1 is 654 into V1, I am writing it as X, that is equals to P2 we have to find, into V2. V2 is equals to 0.6X. So always remember, in such examples the main volume that will be eliminated, so X value will be always eliminated. So now what is the answer? P2 is equals to 654 divided by 0.6, that is equals to 6540 divided by 6. So answer will be equal to 1090. So this is equal to 1090 mm of Hg P2. So this will be the answer, right? Now let's go ahead with the next numerical. Now see, a cylinder of 20 liter capacity contains a gas at atmospheric pressure. Now how many flasks of this 200 centimeter cube capacity can be filled from it at 1 atmospheric pressure? Again, the temperature is remaining constant. So you are here again, you have to apply the Boyle's law. Alright, now I think here there is some mistake. Here it is I think the question here is little bit wrong. I think this is containing 20 liter. Yeah, so this is 1 atmospheric pressure and this is at 100 atmospheric pressure. Here there is 100 atmospheric pressure. So what they are asking, there is a flask. See, I say one flask is there. In this flask there is gas. Now this flask is having volume that is equals to 20 liter and pressure is equals to 100 atmospheric pressure. Now what they are asking is that from this I will fill small flask. Now this flask are having volume that is equals to 200 centimeter cube. 200 centimeter cube, and they are asking that the pressure is 1 atmospheric pressure. So from this bigger flask, how many smaller flask I can prepare? Now here remember one thing, what we are going to do is you have to apply Boyle's law such that it is N1 P1 V1 that's equals to N2 P2 and V2. Now you have the data, that is, say P1 you are having 100 atm. V1 you are having 20 liters, so that is equals to 20 into 1000 centimeter cube. Alright, so this is 20,000 centimeter cube, because your second volume is in centimeter cube. Alright, so remember 1 liter is equal to 1000 centimeter cube. So V1. Now N1, how many flask? So there is only one flask, N1 is 1. Now here let's write P2. P2 what they have given is 1 atm. V2 what they have given is 200 centimeter cube, and I have to find N2. How many such flask I have to prepare? So now when I apply, N1 is 1 into P1 is 100 into V1 is 20,000, that is equals to N2 I have to find. P2 is 1 and V2 is 200. So this 200 part I will cancel. So N2 will come out to be equal to 10, 1, 2 and 3. So 10,000 flask will be filled of pressure 1 atm and volume 200 centimeter cube from a bigger flask of volume 20 liter and pressure 100 atm, right?